Hello, my name is Igor and welcome to another 3D printer review. And this time it is a Creality Sermoon D1. And this package is sent to me by Creality 3D shop in exchange for a review. This is a cubic frame cartesian. This means the hot end is moving in X and Y direction, and the Z direction the printing surface is moving slowly down. This means we can print some taller objects because we don't have the shaking of the printing surface. And finally, this is a printer with a very aesthetic and nice design, but we will see that later when I assemble it. Let's see other specifications. The printing volume is 280 by 260 millimeters in XY direction and 310 millimeters in Z direction. So this is a little bit bigger than average printers like Ender 3 or Ender 5. It has 4.3-inch touch display. It's a direct drive extruder. This means we can print some TPUs, for example, but the maximum printing temperature is 250 degrees Celsius. This means the Creality is using their classic hot end where the Bowden tube is going down, touching the nozzle, and we have this limitation because we don't want to get those fumes from the Teflon on these high temperatures. It has dual Z-axis, 2 screws. This means we have more stability on the printing surface. Maybe I will do some comparison with my Ender 5 Pro, where I have only one Z-axis. It has silent mainboard, smart sensor, and but it still has the manual bed leveling. But I think it should have those yellow stronger springs, so they hold the position longer, and we don't have to do this bed leveling too often. I will do unboxing and assembling, and then I will take a closer look again, because I can see some interesting things here, that it use the linear rods and not wheels, at least on this x-axis, but I will see that when it's assembled. So let's see what's in the box. This is really big and heavy box, so I have to move the camera much higher than usual. In this first layer I have here I think these are doors. Second layer, another 2 side panels. Black alloy extrusions. Oh, a lead screw inside the alloy extrusion. Another side panel, probably hole for the spool holder. These are those vertical alloy extrusions. They look really good in real life. Box with accessories, spool holder, bolt screws, spool holder, some screws and nuts, SD card reader, power cable, stick tape, I don't need that, some covers and some additional tools. I can see, for example, a wrench for the nozzle. An open-end wrench, maybe for the heat block. Another part for the spool holder. And this is what I like now. Usually the sample filaments is on the spool. PLA 200 grams in white color. This is the top frame. And I'm slowly running out of the space on my desk. It's a user manual, and this is the bottom part, Y-axis, which holds the printing surface, and it is this texture glass, and this is the bottom frame, and the box is empty. And this is the first time that all parts couldn't fit on my desk during the assembling, so I will place this printing bed separately until I don't need it for the assembling. So this is the base and all the electronics is below it. This is good because if I have the enclosure, the electronics is a little bit separated, prevent from bigger heat, but it is not fully enclosed, but I will talk about that later. And what I need now is the user manual. First step is installing the profile. These rounded alloy extrusions. But it is very important to pay attention to the type and the position of these alloy extrusions. Now I noticed all 4 alloy extrusions are labeled and numbered, so this one is number 4. And in user manual we also have these numbers, so in this order that's the easiest way. Bolts are also labeled, so take them out of the bag only when you really need them. This one is number 1, this is number 4. Number 3. And number 2. Well, I could screw in the bolts with my hand and now I have to tie them. Second step is installing the 2040 profiles. I believe there will be some kind of holder for the Z-axis lead screws. And don't forget the lead screw is inside this hole. This means they are very good protected during the shipping, but if you take off this foil and you forget about it, they may fall down. So pay attention to this so they will not be damaged. And it's good that these alloy extrusions are also labeled, so we have left and right side, and we have the arrow to see which side is up. And they have to be screwed in with the 2 M4x14 bolts. And what is really nice that they have to be screwed from the top, so I don't have to turn again the printer, so not from the bottom side. And the third step is installing the printing platform. And this step is very important. After installation the printing platform, I have to check these V-slot wheels. On this side they are fixed, but on this side we have this eccentric nut, and with open-end wrench I have to adjust the tightening of this V-slot wheel. As you can see, I can rotate these wheels with my hands, so they are not tight, and I have to rotate these eccentric nuts. And now I cannot rotate them with my hand, so they are tight. Don't over tie them, only until you cannot move them with your hand. Same on the other side, and then you have to check does it move smoothly. Just in case, I had one case that I could not rotate this eccentric nut, it was too tight with this bolt. So that just use your Allen key and just a little bit unloose this bolt, and then you should move freely the eccentric nut. Step 4 is installing the lead screws. But be careful when you are touching them, there is some grease on the lead screw. So probably you want to wash your hands after this before you touch the printing surface. So I lift the printing platform with my hand and then tighten the screws. At this moment I'm not sure is this left like this on purpose, because I can see these are those self-locking nuts, and maybe the freedom of the movement of the T-nuts is left on the purpose, because I cannot see in the manual any instructions to tie them, because they only have to support this printing platform in Z direction. Now before I tie these couplings, there is something I cannot see in the user manual. That is to set these to be horizontal, well actually perpendicular to this alloy extrusion to have that nice squared printed objects. I don't know, my solution will be that I will use this angle and support here on one side first, and now I will tie the coupling, and I will repeat this on the other side. Now I can wash my hands from the grease. Step 5 is installing the top frame here. First I will install the filament guide. There are two holes on this frame, and then it will help me to orient the top frame on the printer. So this filament guide is on the back right side. And now I have to tighten these 4 bolts in 4 corners from the top into this vertical extrusion. And these smaller bolts from the side of this 2040 alloy extrusion here. The other side. Step 6 is the wire connection, and it has to check is the voltage set correctly, but I noticed that on mine there is no switch. So this is the power switch and the connection for the power cable, but there is no switch to set the voltage. This means this should be automatically. In case you have that switch, check that it is set correctly, the voltage for your country. It's time to remove this protection foil from the printing surface because some wires are here on the bottom. I will have this one on printing surface so far, but now I can access to these wires. I will start with this 24 pin. The next one is this 10 pin. And then these two cables which connects the hotbed. I can see all other cables are connected except this one. This is the filament detector, but the filament sensor is not mounted yet, so I will connect this later. Step 7 is the wire management, and this is what I liked. So I had a lot of problems with Ender 5 Pro where to place those wires, but here we actually have slots or holders for these wires. And we have 3 holders here until the bottom. And similar on the other side here. Steps 8, 9, 10, 11 are mounting these acrylic sides, but be careful because you will need M4x8, but not this one. These are countersunk screws, but these with the flat surface and rounded head. And I'm starting with the left side. First I have to remove this protection foil. And the side where I have these 2 holes in the middle goes up. I started with 2 upper bolts and then it is easy to finish the rest. Next one is the back side, and here we have this hole for the power cable and switch. I'm missing some kind of holder because I cannot grab this alloy extrusion because there is this plexiglass. And now I'm installing the right side. You can recognize it, there is a hole for the spool holder and there is I think it's a filament detector. But first, before I mount this right acrylic glass, I have to mount the spool holder. There are two holes for the balls, but it will be a little bit easier to mount it before I fix this cable. And now I can mount the right side, so hole goes here on the spool holder. And this is the filament sensor, goes on the back side. And now mounting the left and right door. M4x8 countersunk head bolts. I will start with the right one, so this is the position, this is the holder. And there are two holes in this alloy extrusion. And same with the left door. I want to insert the filament sensor cable. There is a hole here in the acrylic glass. Step 12 is installing the profile cover and the power cable. They are not labeled, so probably they are equal. Now the power cable. Now I can remove the protection foil from the glass. I checked the motors are working correctly, but before I start with the bed leveling, I noticed that I cannot do the homing because the Z limit switch is broken. And I noticed in the Facebook group for the Sermoon D1 that this is a common problem. Creality knows about it and they are improving the packaging to protect this Z limit switch. Just in case, if you have this kind of problem, I will show you how to replace it. In the first step, I will remove the limit switch with these two bolts. And also it looks like I can pull out the wires. Well, this is how it looks like, the broken limit switch. And it should look like something like this. This is similar, but without this wheel. This is for some other printer I have. But I will not install this one, but I will wait for the replacement from the Creality. But if you decide to use your own limit switch or without wiring, important is to know that it has to be normally closed. Let me show you. If I set the homing command now, I connected these two wires on the Z switch, and I will separate them now. So this means that when the switch is pressed, they have to be separated. Usually you can find the writing on the limit switch, but just in case if you cannot see it, you can use some multimeter. And this is the continuity tester. So this is closed, normally closed, and the limit switch is pressed, it breaks the circuit. So if I would use this switch, I have to connect these two wires. It is not important which goes where, because it is just a switch. But after a few weeks, I get this switch from the Creality 3D shop. And the wire is already on, only I have to mount it and plug this end here. And I don't have to go to the main board, because there is a connector close to the position of the limit switch. Well, it will be a little bit hard to record it on camera, but the point is that, okay, first I have to remove the zip tie carefully, not to break some other wires. And I have to pull out the Z limit switch, but I can see they use some hot glue. Let me try to pull it out. Okay, it's not that easy, because first I have to melt the hot glue. First I try to cut out the hot glue as much as possible. And now, well, soldering iron would be better, but currently this is what I have here down in the basement. Ah, here it is. And now replace it with the other cable. And now mount the limit switch. First I will screw in the two bolts until I can see they come out from the other side, just a little bit, and then I can mount to their position. Now let's test it. Again, homing. Okay, I press with my finger just in case, and it's working now. And now I will let it to finish the homing process. It's here. It's time for bed leveling, but these instructions are a little bit confusing to me. And from steps 13 to 17 is the bed leveling. And it said go settings, move it down, and then it says remove the motor. Don't remove the motor, just disable it with this button. But in next step it says go again to the setting, move up now 10 millimeters and do the homing, auto home. And then on step 15 it says go to the leveling, and this is so-called assisted manual bed leveling. So maybe this is for completely manual bed leveling, and these instructions are for the assisted bed leveling, where by pressing the button the nozzle will be moved to the certain point, and you have to rotate the knobs to adjust the position of the nozzle. Anyway, for me, I will go first to settings, move, and do first the auto homing. Now the nozzle is on -10, -10. This is this corner, and it is off the bed. That's good, because it will not hit the nozzle if your bed is not set correctly. For example, the springs are not tight, and otherwise maybe the nozzle would hit the printing surface. Now I want visually to check that the nozzle is above the printing surface. If that's not the case, then I have to compress the springs more, but here I can see at least 1 or 2 millimeters I have between the nozzle and the top of the printing surface. Back leveling, and it do the auto homing again, and now waiting to choose the point and set the knobs. Usually I start with the left front corner. And now with a piece of paper I will set the distance between nozzle and printing surface until I get that friction, minimal friction between these two objects. Now going to the point 3. And repeat the same. Point 4. Five. And in the center. In the center only to check, because I cannot move anything, but yes, I also had that friction, and actually now the bed is leveled. I noticed a small issue. When I press the button for the leveling, the nozzle is not exactly above the knob. Especially the rare ones, they are maybe 3 centimeters more to the back and maybe 1 centimeter to the side. Not a big deal, but more precisely or less steps is required for the bed leveling if they are exactly above the knob. Not a big deal, it can be fixed with the firmware, but I hope they already know about this problem, but I will inform the Creality about this too. This is the touchscreen. It is very sensitive, one of the best I saw on the printer, so I don't have to press it with my finger, I just have to touch it like a smartphone. And user interface is very simple, maybe even too simple for my taste. So we have the printing here, let's see the temperature, here we have preset for PLA or ABS, or we can set the temperatures manually for the nozzle or the heat bed, or set the cooling. Very nice that I can enter the number. I don't have to press the arrows, but I can enter the number, so that's very positive thing. Okay, cooling fan disable, and we have in the settings the leveling. I did that already. Refuel, change the filament. Here we can disable or enable the stepper, change the language, printer info, or the move. Here if I press this button it will be the auto homing, or I can move the X, Y, Z axis in different directions, or I can enter here directly the coordinate. Printer info. So it is very simple, but as I mentioned, maybe even too simple for my taste. Because I know where can I set the E-steps or I know some advanced functions. Preheat PLA, and it's time to melt some plastic. And in the meantime I will insert this SD card. I like that it is the bigger one from this side here. Print. Well, it looks like I don't have anything on SD card. It's a pity, because I always suggest to print something from the SD card, because the G code is prepared by the manufacturer. And if there is any problem, you know that this is not resolved by the slicer. But in this case, my first print has to be from the slicer prepared by me. This is the content of the SD card, and as you can see in the root we don't have any G codes, that's why I couldn't see any. So here we have the user manual, probably the same like the printed version. Software and drivers, so we have some drivers and the Creality slicer, but I will not use the Creality slicer. I have several printers and I want to use the Cura, so I'll try to set up the profile for the Sermoon. We have some troubleshooting, PDF and JPEG. Here we have some models, and here there are some G codes. Oh, but I will not test these ones for the first prints because they last 9, 12, 13 hours. Operation video how to instruct, so maybe you don't need my instructions because this one may be better. And nothing else. So I have to prepare the slicer for the Sermoon 3D printer. This is the latest Ultimaker Cura. Add new printer, add non-network printer, and search for Creality. And unfortunately the Sermoon D1 is not in this list yet. So I will just use the Creality Ender 5, but I will rename it to Sermoon D1. And all I will change is the printing surface and the volume. And nothing else will be changed here. And I can now insert one STL file, and only one thing I will change here, and that's the retraction. I will reduce it because this is direct drive and I don't need big retraction. So far I will test it with 1.5 millimeters. Reading of the filament is not that smooth here. In the meantime, this is what we can see during the printing. The temperature, this is the percentage, and probably time when the printing was started. We can stop or pause the printing, or we can adjust the printing speed, probably in percentage, nozzle temperature or bed temperature. And we can enable or disable the fan. We cannot set the fan in percentage. And here we can do some fine adjusting for the Z-axis. It is hard to find a good angle to monitor, to record the printing, but maybe this one through the glass is fine for the live view, but for camera no. Maybe for the camera this is the best angle over this corner. And the printing is finished. Quick check for the layer adhesion until it's hot. Oh, it sticks quite good. I'm not sure why the scree didn't stick too well, so I have to remove it during the printing, but I'll wait for the wet surface to cool down and then I will remove the cube. Well, the printing surface is only 39 degrees Celsius, but let's see. Ah, it was very easy to remove it. Oh. So the dimensions are quite good. Let's see the quality of the surface. Well, I can see some lines here on the Z-axis. I really like this surface. This was the first layer. I'm not sure it's visible, the light breaking on it. Very interesting texture. I would say, I don't know, average cube. Now I cleaned the surface because I didn't do it for the first time, just a little bit, and then I will print a Benchy. I want to remove the bed to wash it, but it's not so easily removable, so this clip has to be rotated, it cannot be pulled down completely. But it looks like the rear clips are fixed. I just want to wash it under the tap. I had some problem with the bed adhesion, so I used the printer fix. And now even the skirt was printed correctly. I was late, I couldn't catch the end of the printing. Now the bed surface is 54 degrees Celsius. But it still holds quite good. But I used some printer fix, as I mentioned, on the bed surface, but you can use a hairspray, that's similar effect. 38 degree the bed temperature. Oh, it stick good. This printer fix is Too good. Okay, let's analyze this Benchy. I can see some horizontal lines here, but not too big, so the overhang is good. The bridging, again, here I can see some lines, but not bad actually. A little bit better than average Benchy. Let's try to remove the skirt. Okay. And since this is a direct drive extruder, I want to test it with some flexible filament with TPU. These are my settings in Cura. I use the generic TPU profile, and of course I reduce the retraction to 1 mm and the fan speed to 10%. I left the speed, I didn't change it. It is the speed of PLA printing. So far I can tell already that this is far the best 3D printed flex filament. I think I printed this corner guard on 5 different printers with direct drive extruder, and I think this is far the best, but I will see at the end. Not so perfect anymore. I can see some stringing or some seams, but I will analyze it when the object will be printed. Pay attention, just for testing I try to switch off and on the fan. With the G code it was set to 10%, but when I turn it off and back on, now I can hear that it's on full power, so be careful, better if you don't mess with the fan. Unfortunately we cannot set the strength of the fan in the firmware. Printing is almost finished, and I printed this with the speed of the PLA. Printing is finished. Let's quickly check the bed adhesion. It was okay, but I would expect a little bit stronger, and it's not that perfect, the printing, so I can see this stringing and some seams here, and I can see some holes here on the top layer. So for example here I would like to raise the flow rate or the E-steps or something like that, but I cannot now in this simplified user interface. This stringing is very easy to remove. It's typical for the flex filament. And I quickly clean it so you can see how flexible is this filament, and it can print it without any problems, but definitely I think I should play a little bit more with the settings. Actually I don't need so many corner guards, but now this is my standard for TPU testing. Currently only this printer is connected to this power meter, and currently it is 18.38, and I want to check, now it is 5 minutes, I want to check what will be the power consumption after 1 hour of printing. After exactly 1 hour of printing with these parameters, new number on the power meter is 18.48. This means the power consumption of the Sermoon D1 with these parameters is this, if I subtract these two numbers. One more thing I want to check with this Unity thermal camera, and that is the heating of the bed surface. Is it equal, or there are some cold spots? So I will set 60 degrees Celsius and follow with this camera the heating. And after approximately 2 minutes the temperature stabilized. You can see that mark in the middle, that's from the printer fix, but I would say this is quite good because the heat surface is quite equal. There is no big difference between corners and the center. And this is the rest of the electronics. Below you can see the display and the power supply on the back side. In conclusions and my final thoughts about Sermoon D1. It is really a piece of art. The design is fantastic. It is partly enclosed 3D printer. Unfortunately, only partly. I don't know, they could spend some more time to at least give an option to have some top cover, and then we would have enclosed 3D printer, because the electronic is below it. So one thing which runs it to be perfect enclosed printer is the display. Unfortunately, it is inside, so it will be better if it is somehow outside, so we don't have to open the door if we want to do any kind of modification on the printer. If you are not familiar with printing in enclosure, it is required for ABS, nylon, polycarbonate and similar filaments, and you don't need high temperatures. Maybe 45 degrees Celsius is enough inside, but it is important when you start printing, don't open it to prevent any kind of breeze inside. I really like this direct drive extruder, so it can print even flexible filaments with the speed of PLA, and it's really good. It is a metallic extruder, and I'm a little bit confused with those 3 fans, but it is quiet, so it's not loud like Industry V2. And finally, the Creality moves from those V-slot wheels, and here we have the linear rods on X and Y axis. On the Z axis we have the V-slot wheels, but we have 2 lead screws, so this printing bed is supported on 2 sides, so it's very stable, unlike on my Ender 5 Pro, where it's supported only on one side, and actually the other side is hanging, and this is more stable. I really like this touch display. It is the best touch display I saw on 3D printers, because it's like on a smartphone, just a small slight touch and it reacts. And I really like that finally, when I want to enter the number, I don't have to press arrows up and down. I just click the field and enter the number directly, and it is much faster. So that's how it should work. So user interface is very nicely designed, but it's a little bit too simple. So I'm missing those advanced options from this user interface. It has silent stepper motor drivers on X and Y axis only. I don't know why they didn't use it on the Z axis. I mean, you probably heard in a video when I continuously move the Z axis, you can hear it, it is very loud. For our luck, during the printing, it is not that noticeable because the Z axis is moving only for the short period of time. But it will be better if we have silent stepper motor drivers on all stepper motors. And I'm waiting when we Creality move from that hot end, the limitation, well, on the website it says 250 degrees Celsius. Here in the firmware I can set 260 degrees Celsius, but I wouldn't recommend to go about 240. I'm not sure, I didn't disassemble the hot end yet, but I think that they use the same hot end where the bovden tube is touching the nozzle. And if you go about 240 degrees Celsius continuously, you will get some toxic fumes. So for that, all metal hot end would be recommended. About that firmware, I noticed, as I mentioned, it's too simple, and I noticed a small error when I press the assisted bend leveling. I choose the knob, nozzle to move above the knob. It's not exactly above that screw, because especially on rare knobs it is 3 centimeters more from behind and maybe 1 centimeter to the side. Not a big deal, but less step is needed and more precise is the bed leveling if it is exactly the nozzle above the knob. I explained this in my NDCV2 review video. I will place the link with a timestamp in the description so you can see that I explained there in 2 dimensions. I had some problem with this filament guide, not big deal, but with the PLA, if it is pulled under the angle, it's stuck a little bit. You heard that click during in the video. With TPU I didn't have that problems, and also I had some small problems with the bed adhesion. I thought this is same glass like with my NDCV2, but I noticed with NDCV2 the adhesion is perfect, so it's much better compared to this one. But I had to use some what's this print-a-fix. I'm not sure if it is globally available, but it acts similar like the hairspray, only I don't really have hairspray at home. Well, I hope I mentioned all important things. If I skipped something, please leave me a comment. Thank you for watching and happy printing.